All right, here's our last lesson for Unit 11. So we're going to do systems of linear and quadratic functions. Basically, when it's a system, what you're going to do is you're going to take two different functions and see when those functions cross each other or when they intersect each other. We're going to do it algebraically, and then we're going to do it graphically. We're going to do it both ways. But for these systems, since we're doing one part of the system is going to be a line, and the other part of the system is going to be a parabola. So we got linear and quadratic. There's three possibilities for how these are going to turn out. Probably the most common possibility is this one right here. You're going to have a quadratic, I'm calling this f of x, right here in blue. And then I've got a linear function here in green. And we can see that the quadratic and the linear function intersect at two different places. So they're intersecting here and here. Now, what we're looking for in these problems is when do the two functions equal each other? Now remember, f of x and g of x stand for the y values. F of x is the y values of the blue one. G of x is the y values of the green one. We want to know when are the y values going to be equal to each other on both of the functions, and what's the x value going to be. So there's two solutions, so this is crossing. We don't need to know what the y values are because we already know they're equal to each other. What we want to find out are what are the x values that make the y values equal to each other. So at each of the intersections, you're going to look at those points and find the x values, and those are going to be your solutions. Over here, we've got another possibility. We've got f of x, here's our parabola in blue, and g of x, our line in green, and they're only touching at one point. The line just comes up and kind of kisses the parabola and just moves on. So there's only one point where they're intersecting. Again, we're looking for where f of x is equal to g of x. So that's where the y value of the parabola equals the y value of the linear equation. And we're looking for, not the y value, we're looking for the x value where they're equal to each other. In this case, there's only going to be one x value where they're equal to each other, so there's only one solution. The last possibility is I've got my parabola down here, f of x in blue, and my linear equation in green up there for g of x. We want to know where are they going to be equal to each other. Well, these two never intersect each other. So there's no solutions between those two functions because they never intersect. So you can have two solutions, one solution, or no solutions. And what we're looking for, when we're looking for the solutions of the systems, we're looking for the x values of the intersection. So we don't care about the y because we already know the y is equal to each other. We're looking for the x values where they're equal to each other. All right, so solving algebraically, let's start with that. Start with example 1. We're going to say that f of x is going to be equal to x squared plus 10x minus 7. And g of x is going to be equal to negative 3x minus 7. Okay, so we want to find when f of x is equal to g of x. So f of x is this. g of x is that. So my first step is to replace f of x with x squared plus 10x minus 7, because that's what f of x is equal to. So I'm going to write x squared plus 10x minus 7. And it's equal to g of x, and we know g of x is negative 3x minus 7. Okay, there we have an equation. And what we're going to do is we're going to move everything to one side of the equation. We do want our x to the second term to be positive, so I'm not going to move everything towards the right. I'm going to move everything towards the left so that x squared stays positive. It's just a little bit easier that way. So my first step is to add 3x to both sides. So I'll add it here with the 10x because they're like terms. I'm going to add 7 to both sides. And I'll add it here because those are like terms. So I'm adding that to both sides. And that gives me x squared. 10x and 3x is 13x. The 7s cancel each other out. Over here, these all cancel out. So I get equals 0. Okay, at this point, you've got several methods that you can use in order to solve these. You could use the quadratic formula if you like. A's 1, B's 13, and there's no C over here, so C is 0. So you can use the quadratic formula if you like. You probably would not want to use the completing the square method because this number right here is odd, and that's going to give you fractions to mess around with. So, you know, fractions are scary. So those are the couple methods that you could do. The other method that is probably the best for this one is factoring, because I noticed that I can factor out an x. So that's going to be my first step, is factor out x. I'm left with x plus 13. So this is in factored form now. And when we have something in factored form, we can set our factors equal to 0 using the principle of zero products. If these things are multiplied and they equal 0, that means one of these two things has to be 0. So we're going to write that x could be 0 and x plus 13 could be 0. This one's already solved. We know one of our answers is 0. This one we would have to subtract 13 from both sides. And that tells us our other answer is negative 13. So the answer to the question is 0 and negative 13. Those are the x values where f of x is equal to g of x. So that's the answer to the system. Now, the other question that you could ask is, at what points will these two graphs intersect each other? Well, these are the x values where they will intersect each other. So all you need to do is plug in the x and then find the y. So if you wanted to add the question of what are the coordinates of the intersections, that could be answered just by plugging in 0 into f of x or g of x. It doesn't matter which one. You will get the same answer. And then plugging in negative 13 to f of x or g of x. Doesn't matter which one. You'll get the same answer. I'm going to choose g of x because it looks easier. So I'm going to plug it in. So let's find out the first coordinate. First coordinate, I'm going to plug in for x. I'm going to plug in 0, so I'm going to find g of 0. So I do negative 3. Instead of x, I plug in 0. And negative 3 times 0 is 0. And I get negative 7. So what are the coordinates? The coordinates, I plugged in 0, and I got negative 7. And if you look really quick, if you plug in 0 to both of these x's, you're going to get negative 7 for the f of x1 as well. So that is one of the coordinates of the intersection. 0, negative 7. For the other one, we're going to plug in negative 13 to find the coordinate of the intersection. So I'm going to do g of negative 13. I do negative 3 times negative 13 minus 7. So negative 3 times negative 13 would be positive 39. And 39 minus 7 would be 32. So that tells me that the other intersection point, I plugged in negative 13, and the y value was 32. So if we're looking for the solutions, when f of x equals g of x, our solutions are 0 and negative 13. If we're looking for the coordinates of the intersections, we would plug these x values into one of the functions to get the y value, and that would be 0, negative 7, and negative 13, 32. All right, so that is solving it algebraically. Let's solve one graphically. Example 2, solving graphically. Okay, on example 2, f of x. I'm going to be nice to you and I'm going to give you it in vertex form. Is going to be x plus 1 squared minus 2. And g of x is going to be negative x minus 1. And we're going to find where f of x is equal to g of x. So instead of solving algebraically now, I'm going to graph these. Remember, when we graph them, wherever they intersect, the x values of the intersections are our solutions. So first thing I need to do is I'm going to take f of x and I'm going to look for its vertex. The vertex would be at negative 1, negative 2. The axis of symmetry is going to be x equals negative 1. Let's graph and see what we have so far. I have no idea where this is going to show up, so I'm just making a big graph. All right, so far I've got a point at negative 1, negative 2, so I'm going to go back 1 and down 2. There's my vertex. That means my axis of symmetry is going directly down it. So there's the line x equals negative 1. Okay, so I usually like you guys to have 5 points on there. So I've got x equals negative 1. Now let's plug in 0 for x and see if I can get a point on this side, because it'll give me a point on the other side. Okay, so I'm going to plug in 0. So let's plug in 0 for x. So I get 0 plus 1 squared minus 2. When I plug in 0, I get 1 squared minus 2. And this is 1 minus 2, which is negative 1. So I plugged in 0, and I got negative 1 for y. So 0, negative 1 is right here. That's one of the points on my parabola. My other point would be over here at negative 2, negative 1, because the axis of symmetry is a mirror image, makes the parabola a mirror image on either side. All right, let's plug in another point. So I got negative 1. I plugged in x equals 0. Now let's plug in x equals 1. So I'm going to do f of 1. So I get 1 plus 1 squared minus 2. This yields 2 squared minus 2. Got an email. And this is 4 minus 2, which is 2. So I plugged in 1. And I got 2 for the y value. So 1, 2 would be here, which means over here at, what's that, negative 3, 2, I've got another point. I think that's going to be enough. So let's just make our parabola. Almost did it. All right, so there I've got my parabola. This is f of x. Next, let us graph g of x. G of x is a linear equation. So in a linear equation, we look for our slope, which is m, and we look for our y-intercept, which is b. Our slope is negative 1 over 1. Our y-intercept, what is that? Our y-intercept is negative 1. So I'm going to start by graphing negative 1. Negative 1 would be right here, right on top. Seriously, there's nobody here. Bells are not necessary. Or was I? Ah, yes. So I put in my y-intercept right there. So now I'm going to use my slope. My slope says negative 1 over 1, so I'm going to go down 1 over 1. Down 1 over 1. Well, that's not the correct direction. I need to be going the other direction. So instead of going down 1 over 1, I'm going to go up 1, backwards 1. Nope, not intersecting there. Up 1, backwards 1. Not intersecting there. Up 1, backwards 1. Yes, there's my intersection. All right, so here's g of x. That's my linear equation. And we can see that it is intersecting at 2 points. One of the points is here. One of the points is there. The intersection points, this point is at negative 1, 2, 3, up 2, so that's negative 3, 2. This intersection point over here is at 0, negative 1. Now, if we're looking to find where f of x equals g of x, then our answer for this one is only the x values, negative 3 and 0. So x equals 0 and negative 3 are our two solutions for the system. These are our intersection points. But these are the solutions for where f of x equals g of x, 0 and negative 3. That is it. You have now finished Unit 11. Bye-bye.